Hello everyone, this is Chinnaiah Kalpana here. In this video, we are going to solve a differential equation using integrating factors. So let's get going. Problem solve x times 3y dx plus 2x dy plus 8y power 4 into y dx plus 3x dy equal to 0. Right? So we are given a differential equation x into 3y dx plus 2x dy plus 8y power 4 into y dx plus 3x dy equal to 0, right? We can write this as x into 3y dx plus 2x dy plus y power 4 into, I'll multiply these two terms with this 8. Then I'll get 8y dx plus 8 3s are 24x dy equal to 0, right? Now we can write this x as x into 1, right? Since x into 1 is x, right? And we can write this x as x power 0, and we can write y equal to y power 0 since y power 0 is 1, right? You can write x as x power 1, okay, not x power 0. And this 1 as y power 0. So you'll get into y power 0. So you can replace this x by x power 1 into y power 0. Likewise, here you're having y power 4. We can write this y power 4 as 1 into y power 4, right? Since 1 into y power 4 is again y power 4. And you can write this 1 as x power 0. You'll get x power 0 into y power 4. You can replace y power 4 by x power 0 into y power 4. Simply we'll write product of xy. That is product of x power some number into y power some number here. Okay. X power some number into y power number. X power some number into y power some number. Okay. Fine. Now we'll write this x as x power 1 into y power 0 into 3y dx plus 2x dy plus, we can write this y power 4 as x power 0 into y power 4 into 8y dx plus 24x dy equal to 0. Consider the given differential equation as equation 1. Okay. We have written the given differential equation of x power a y power b into my dx plus nx dy plus x power c y power d into py dx plus qxdy equal to 0 form, right? See, we have reduced this into this form where a equal to 1, b equal to 0, m equal to 3, n equal to 2, c equal to 0, d equal to 4, p equal to 8, q equal to 24, right? Which are constants. So consider this reduced equation as equation number 2, where a equal to 1, b equal to 0, c equal to 0, d equal to 4 and m equal to 3. Just by comparing these two, we'll get the constants. I mean the unknowns, otherwise the values of unknowns we can say. Okay. N equal to 2, p equal to a, q equal to 24, right? Since the given differential equation can be written of this form, so here we'll solve this equation using integrating factor x power alpha and y power beta. So here we need to find alpha and beta. Okay, so I'll solve this using two methods in two different videos. Okay, fine. So after finding alpha and beta, we'll substitute alpha and beta in this integrating factor, and later we'll multiply this integrating factor to the given differential equation in order to make the given differential equation an exact equation. and later we'll find the general solution to the given differential equation using the general solution formula of an exact equation. Okay, let's see that. See, here we can check whether the given differential equation is exact or not. We'll check whether it is exact or not. We'll do some verification later after solving the problem. Okay, fine. See, we have A equal to 1, B equal to 0, C equal to 0 and D equal to 4, and M equal to 3, N equal to 2, P equal to 8 and Q equal to 24, right? And here x power alpha, y power beta be the integrating factor. So we need to find alpha and beta. Here we'll find alpha and beta using simple formula. A plus alpha plus 1 by m equal to B plus beta plus 1 by n and C plus alpha plus 1 by p equal to D plus beta plus 1 by q. Right? Let's substitute the values of A, B, C, D, M, N, P and Q. Right? Now this equation becomes 1 plus alpha plus 1 by m 3 equal to B 0 plus beta plus 1 by n 2, which gives us alpha plus 2 by 3 equal to beta plus 1 by 2, or we can write this as 2 times alpha plus 2 equal to 3 times beta plus 1, which gives us 2 alpha plus 4 equal to 3 beta plus 3, right? Now bring this 3 beta to LHS, you will get 2 alpha minus 3 beta equal to, take this 4 to RHS, you will get 3 minus 4, which gives us 2 alpha minus 3 beta equal to minus 1, right? Consider it as equation number A. Now coming to this equation, substitute the values, you will get 0 plus alpha plus 1 by p 8 equal to D 4 plus beta plus 1 by q 24, which gives us alpha plus 1 by 8 equal to beta plus 5 by 24, right? Now we can take this 8 to RHS, you'll get alpha plus 1 equal to 8 times beta plus 5 by 24. 8 ones are 8 threes are. Now bring this 3 to LHS, you'll get 3 times alpha plus 1 equal to beta plus 5, which gives us 3 alpha plus 3 equal to beta plus 5, right? Now bring this beta to LHS and take this 3 to RHS, we'll get 3 alpha minus beta equal to 5 minus 3, which gives us 3 alpha minus beta equal to 2. Consider as equation number sum B. Okay. Now by solving these two equations, we'll get alpha and beta. Let's see that. See, in order to find the values of alpha and beta, we are going to solve these two equations, and here I'm going to eliminate the terms involving beta from these two. Okay. So in order to eliminate beta, we'll just multiply the second equation with 3. Because here we are having 3, so if we get 3 and we subtract this equation from the first equation, the beta gets eliminated. Okay, let's see that. Solving A and B. We have A, that is equation A, and equation B is multiplied by 3, so you'll get 3 3s are 9 alpha minus 3 beta plus 3 2s are 6. Change the signs. Here minus 3 beta plus 3 beta gets cancelled and you'll get 2 alpha minus 9 alpha gives minus 7 alpha equal to minus 1 minus 6 gives minus 7, or 7 alpha equal to 7, we can say from this we'll get alpha equal to 7 by 7, which gives us alpha equal to 1. Therefore, alpha equal to 1. We got alpha equal to 1 by substituting alpha equal to 1 in equation A. We'll find the value of B. We have equation A, 2 alpha minus 3 beta equal to minus 1, right? Okay, by substituting alpha, value of alpha in equation A, we'll get the value of beta. Okay, so what I'll do is I'll just take this term to RHS, then I'll get 2 alpha and I'll bring this minus 1 to LHS, so it becomes plus 1 equal to 3 beta, or we can write this as say 3 beta equal to 2 alpha plus 1. Now substitute alpha, the value of alpha in it, we'll get 3 beta equal to 2 into 1 plus 1, which gives us 3 beta equal to 3, because 2 plus 1 gives 3, right? From this we'll get 3 beta equal to 3, which gives us beta equal to 3 by 3, 1. Therefore, beta equal to 1. So we got alpha and beta values. Therefore, alpha equal to 1 and beta equal to 1. Therefore, alpha equal to 1 and beta equal to 1. So, the integrating factor becomes x power alpha y power beta equal to, since we have alpha equal to 1 and beta equal to 1, then the integrating factor will be x power 1 into y power 1, which is xy. So we got the integrating factor. Now multiplying this integrating factor to the given equation, the given equation becomes exact, right? By multiplying the integrating factor to the given differential equation, the given differential equation is reduced to exact equation. Fine. Now multiplying integrating factor xy to the given differential equation or equation 1, then we'll get xy into first equation, x times 3y dx plus 2x dy plus 8y power 4 into y dx plus 3x dy equal to 0. This becomes xy into 3xy dx plus 2x square dy plus 8y power 5 dx plus 8 3s are 24 xy power 4 dy equal to 0, right? Which gives us 3x square y square dx, 3x into x square y into y square dx plus 2 x into x square x cube into y dy plus 8 x y into y power 5 is y power 6 dx plus 24 x into x square, y into y power 4 gives y power 5 into dy equal to 0, right? Now take dx common from these two terms and dy common from these two, right? Then you'll get 3x square y square plus 8x y power 6 into dx plus 2x cube y plus 24x square y power 5 into dy equal to 0, right? Consider it as equation number 3. Now let's see whether equation 3 is exact or not. If see, this is of the form mdx plus ndy equal to 0 for m equal to 3x square y square plus 8x y power 6, and for n equal to 2x cube y plus 24x square y power 5. If the partial derivative of m with respect to y equal to partial derivative of n with respect to x, then we can say that the reduced equation, that is the equation 3, is exact. Okay, let's check it out. This is of the form mdx plus ndy equal to 0, where m equal to 3x square y square plus 8x y power 6 and n equal to 2x cube y plus 24x square y power 5. Okay, now we are going to find the partial derivative of m with respect to y, and later we'll go for partial derivative of n with respect to x. So this is equals to dou by dou y of m 3x square y square plus 8x y power 6. So here we need to find the partial derivatives of these two terms with respect to y. So here x is considered as constant. So here x square and x are constant. So we'll write it as 3y square into partial derivative of, here x square is constant, right? So you'll get 3x square into partial derivative of y square with respect to y plus constant 8x into partial derivative of y power 6 with respect to y. Here 3x square is constant, here 8x is constant, right? So this gives us 3x square into partial derivative of y square with respect to y is 2y plus 8x into partial derivative of y power 6 with respect to y is 6y power 5, which gives us 3 to the 6 x square y plus 8 6 are 48 x y power 5. Okay, let's now find the partial derivative of n with respect to x. Here we need to find partial derivative with respect to x, so y is treated as constant. So you'll get, here y is constant, and in the second term, okay, 2 and y are constant, and here 24 and y power 5 are constants. Okay, so you'll get 2y into partial derivative of x cube with respect to x plus constant 24 y power 5 into partial derivative of x square with respect to x. This gives us 2y into partial derivative of x cube with respect to x is 3x square plus 24y power 5 into partial derivative of x square with respect to x is 2x, which gives us 2 3 is 6 x square y plus 24 2s are 48 x y power 5. So you got the same answer. It shows that partial derivative of m with respect to y equal to partial derivative of n with respect to x, right? From this we can say that equation 3 is exact. Therefore, partial derivative of m with respect to y equal to partial derivative of n with respect to x equal to 6x square y plus 48x y power 5, which shows that equation 3 is exact. Equation 3 is exact, right? Now we'll find the solution to the given differential equation using the general solution to this equation 3, which is given by the formula of the general solution of exact equation. The general solution is given by integral over m dx, treating y as constant, plus integral of terms of n free from x into dy equal to c. For m equal to, we'll consider the m and n of the reduced equation, since the reduced equation is of the form mdx plus ndy equal to 0, where m equal to 3x square y square plus 8x y power 6 and n equal to 2x cube y plus 24x square y power 5. Okay, for m equal to 3x square y square plus 8x y power 6 and n equal to 2x cube y plus 24x square y power 5. Okay, so we'll find each term or each integral separately for our convenience. I'll begin with the first one. We have m 3x square y square plus 8x y power 6 into dx. Here we have to treat y as constant, right? So y square is treated as constant, y power 6 is treated as constant, and also 3 and 8 are constants, right? We'll write this as 3 y square into integral x square dx plus 8 y power 6 into x dx, which gives us 3y square into integral x square dx is x cubed by 3 plus 8 y power 6 into integral x dx is x square by 2, which gives us x cubed y square plus 4x square y power 6. Okay, so this is the result obtained from the first integral. Okay, x cube y power 6, sorry it's 2, right, y square plus 4 x square y power 6. Now coming to the second integral. Terms of n free from x into dy. For n equal to 2x cube y plus 24x square y square. So just identify the term which is free from x, right? In both the terms we are having x, so there is no such free term which is free, there is no such term which is free from x, right? So we'll get integral of terms of n free from x into dy is 0. So the result obtained from the second integral is 0. Right? Now coming to the general solution. Therefore, the general solution is, the result obtained from the first integral is x cube y square plus 4x square y power 6 plus the result obtained from the second integral is 0 equal to c. Then x cube y square plus 4x square y power 6 equal to 0 is the required solution, right? Therefore, x cube y square plus 4x square y power 6 equal to c is the required solution. This completes the problem. Okay, fine. Now let's verify that given differential equation is exact or not. Okay, so this is the required solution, or we can just take x square y square common from these two terms. Okay, then we'll get x square y square of x plus 4y power 4 equal to c. We are given differential equation x into 3y dx plus 2x dy plus 8y power 4 into y dx plus 3x dy equal to 0, right? We can write this as 3x y dx plus 2x square dy plus 8y power 5 dx plus 8 3 is a 24 xy power 4 dy equal to 0, right? Now let's take dx common from these two terms and dy common from these two terms. Okay, we'll get 3xy plus 8y power 5 into dx plus 2x square plus 24xy power 4 into dy equal to 0, which is of mdx plus ndy equal to 0 form, right? For m equal to 3x plus 8y power 5 and for n equal to 2x square plus 24xy power 4, right? If the partial derivative of m with respect to y equal to partial derivative of n with respect to x, then we can say that the given differential equation is exact. If it is not equal to 0, then we can say that it is non-exact. Okay, let's find partial derivatives of m with respect to y and partial derivative of n with respect to x. Okay. I'll begin with partial derivative of m with respect to y. This equals to dou y of m 3xy plus 8y power 5. Since we need to find partial derivative with respect to y, so 3x is treated as constant or x is treated as constant. Okay, and here 8 is constant, so we'll write this as 3x into partial derivative of y with respect to y plus 8 into partial derivative of y power 5 with respect to y, which gives us 3x into partial derivative of y with respect to y is 1. 3x into 1 plus 8 into partial derivative of y power 5 with respect to y is 5y power 4, which gives us 3x plus 8 5 is 40 y power 4, right? Let's now find partial derivative of n with respect to x. Partial derivative of n with respect to x for n equal to 2x square plus 24xy power 4. Since we need to find partial derivative with respect to x, so here y is treated as constant. In the first term 2 is constant and in the second term 24y power 4 are constants, right? So we can write this as 2 into partial derivative of x square with respect to x plus 24y power 4 into partial derivative of x with respect to x, which gives us 2 into partial derivative of x square with respect to x is 2x plus 24y power 4 into partial derivative of x with respect to x is 1, which gives us 2 2 is a 4x plus 24y power 4. Just by observing these two, we can say that partial derivative of m with respect to y is not equal to partial derivative of n with respect to x. So we can say that the given differential equation is not exact. Since it is not exact, so we have applied integrating factor to find the general solution to this given equation, right? Fine. So we have solved the differential equation using integrating factor in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.